Afternoon, time for another video of the walking project. There you go, this is actually just another rig that I've made up with some legs that I'm proposing to make for the walker. So if I can sort of get that way down, you can sort of have a look at the profile and how the height of the thing and how it looks. Essentially what I've done is, move that out of the way. I've actually taken these templates here. This is the bottom of the leg, and this one's on the top there, which sort of fits together a bit like that. Okay, well I've taken that template and cut two legs out of high density polyethylene HDPE, about 15mm thick, and it's quite tough. I mean, if I actually grab hold of it here, you see, yeah. I'm not going to pretend I'm particularly amazingly strong, but there's certainly enough there to hold, 20 kilos or more. So the legs certainly are substantial enough, and of course we got the same cylinders. These are the 20mm diameter with the 50mm stroke, single acting spring return, and the 4mm pneumatic pipe coming off of there. Okay, 4 cylinders with the 4 pipes going to the valve set there. Again, you've got a cam operation as before. You can see everything, nothing really has changed. I've tidied up a little bit, but essentially it's the same thing. And then the pipes now going down. I'll just pop the compressor on the floor there. This is a 12-volt tire inflator compressor. It still has the pressure switch there, and a relay, an ordinary automotive relay, the on-off switch, going to a 12-volt SLA 16 ampere hour battery. It's reasonably well charged. I'll start him up on the switch. Okay, so you can sort of see there, it's just cutting out around about just under 3 bar, which is what I'm proposing to run the thing at anyway, so I'll just leave that down there popping away. For the valve set and the motor, we have again a little motor speed controller here. Cheap little thing, just really using for the testing purposes. And then another SLA battery. This one is a 12 ampere hour 12 volt. I'm just going to plug that back in, make sure it's red to red and black to black. Good, so that's that. What I'm going to do is just do a quick test, and then you can actually just watch the operation. Okay, so I'm just going to turn him on now, if I can get that in the right place. Try and get it going. There we go. What I'm going to do is just let it operate for a bit, and you can sort of see. If I go back down here, you can sort of see the leg movement around. The way it's configured at the present moment, it will be as if it's walking away from this back wall. Okay, as you can sort of see, each step is actually quite a distance. So it looks like even at this speed it would be quite quick. At the present moment, let's have a look at the pressure. Sort of bouncing around about the 2 bar mark, I think that is. Okay, I'm just going to increase the speed to full. As you can see, the legs are really going for it now. And if we go to the compressor again, you can see it's just slightly under 2 bar, about 25 psi. Okay, so there you go, that's going well. I'll turn this back off again because it's a bit noisy. There we go. Turn that back on, turn that down. There we go. So, everything seems to be going okay at the present moment. I've just done just weighed on the kitchen scales this whole assembly, the 2 legs, and also the spine chassis that it's all bolted to, and that actually came in at about 2.6 kilos, and I'm pretty impressed with that. I think that's quite good. I've decided that just purely on the size of the thing, I'm probably going to have to go to three legs aside to make it a 6-leg robot rather than an 8-legged one, purely and simply because it's just going to be massive otherwise. The way it works is if I actually move this leg back, you can sort of see here that I've only got a little bit of room, I suppose about 50 millimeters, maybe a bit less, between the two legs before they start hitting each other. So I can't actually make the gap between the legs much smaller than they are already. And of course, with another leg sort of here, then you're dealing with a fairly large robot. And of course, if I had another one there, you know, this featherweight could be a meter long. Well, in some of the arenas, that's about half the arena. So to actually make it some reasonable size, it looks like I'm going to have to just make it a 6-leg walker rather than an 8-leg. The other thing is, I'm not sure about how I'm going to steer it. I was going to do a thing where essentially this spine here would be articulated, and so the robot would actually literally steer a bit like a car. You know, the legs would all bend and twist. But again, I don't think I've got the length to do that. It's just going to end up with this very unwieldy looking thing. So I think I'm going to have to go over to tank steer, which I can do it, but I'm just a bit bored with it really. I wanted to do something a bit different. Still, I've got some ideas of using asymmetry on the legs to see if I can actually do something different to that. But you know, I'm not sure at the present moment what I'm going to do. So all things being equal, what I'm going to do is plan on making it a 6-leg walker and tank steer. That's where I'm going for at the moment. But we'll just have to see how things go. I'll just give it one more test so you can see it going. I'll turn the cam on, and then there we go. There you go. Well, thanks for watching. Bye for now.